So in 5A is talking about some basic definitions that you're going to have to understand to be able to do some of this. So I'm going to kind of go slow. So this says statistics is a science of collecting, organizing, and interpreting data. Statistics are the data that describe or summarize something. I'm not ever going to ask you what these terms mean, but I think that it's important for you to know, just because you're going to have to understand what the stuff means in order to answer some of the questions. So this basic definition, statistics is a science of collecting, organizing, and interpreting data. Well, you know that. Like, people do surveys all the time in in today's climate, good night, how many political surveys do we see on the news all the time, or how many surveys about this or that? So we know that kind of can wrap our mind around statistics, just because we've heard what percentage of people think this way or think that way. And the actual statistics are also described as the data that describe or summarize something. So our actual math that we're talking about that describes something. Okay, and so when we get into talking about statistics, we could talk about the population. These definitions you might want to jot down. Population, because you're going to have to understand, in order to do some of the lab, you're going to have to understand what these words mean. The population is the complete set of people or things being studied. The complete set of people or things being studied. Okay, and when I think about that, that can be a little bit confusing. Population is the complete set of people or things being studied. When we talk about, let's say I wanted to survey college students about whether they wanted to go to school virtually from now on or show up in class from now on, okay, and I was just taking a survey. Well, if I wanted the population of college students, we would be talking about every single college student, right? So that would be in other states, maybe even in other nations. So that would be a broad. Population is the complete set of people that you're trying to get information from, okay? Then we break it down to, well, what is a sample? A sample is described as the subset of the population. And when you think about it, it would be really, really, really difficult to interview every single college student everywhere, right? I mean, that's almost impossible. So that's why we have a sample, is a subset of the population from which the raw data are actually obtained. Let's see if I can make this pen a little bit thinner and change the color. Okay, so a subset of the population from which the raw data are actually obtained. So if we describe the population as every single college student, right, a sample of that might be, okay, I'm going to survey 100 students at Pulaski Tech. I'm going to survey 100 students at Fayetteville, right? I'm going to survey 100 students from at least one college in every state, right? I need a sample. There's no way I would be able to survey every single college student. So you want to break it down to, what is your sample size? That's the difference between population and sample. Okay? Population is everybody that you're trying to get information from, but your sample is your smaller set that you actually got the information from. So population parameters are specific numbers describing the characteristics of the population. Okay, so that would be like when I'm saying I want to just focus on 100 students in Pulaski Tech. What are my parameters? Who am I actually looking at? Okay, specific numbers describing the characteristics of the population. Now, the population is the whole group, and we're going to talk about these words in some examples down here that'll help you understand a little bit better. But sample statistics are the numbers describing the characteristics of the sample, found by consolidating and summarizing the raw data collected from the sample. So I'm going to, let's see, so we've got numbers. Numbers describe the characteristics of the sample. Um, going to summarize the raw data. Okay, summarize the raw data. Um, so let's put these words in context here. So we've got an example, and it basically is asking us, okay, well, here's our example problem. Now tell me what these things mean in this problem. So agricultural inspectors from Jefferson County measure the levels of residue from 3 common pesticides on 25 ears of corn from each of the 104 corn producing farms in the country. Okay, so we got an agricultural inspector. He's going to measure the levels of residue from 3 common pesticides on 25 ears of corn from each of the 104 corn producing farms in the county. Okay, I think I said country a while ago. Sorry about that. So what is our population? What are they trying to, what is the group of things they're trying to look at? I would say they're trying to look at all the corn in Jefferson County. They're trying to look at all the corn in Jefferson County. That's their population. They're trying to figure out something about those ears of corn, whether they have the pesticide or not. And so that would be our population. Our sample, well, it's not possible for them to look at every single ear of corn in Jefferson County. That's not realistic. So what did they do? They came up with a sample, and the sample is the what? Yeah, the 25 ears of corn from each of the farms. So the sample is going to be 25 ears of corn from each farm. Can't look at all the ears of corn, so they're going to look at 25 from each farm. What are their population parameters? Well, they're trying to figure out what the average levels of residue from 3 pesticides for all corn grown in the county. So let me see if I can word that a little bit better. Remember that residue of 3 pesticides. Okay, and this is going back to the word population, right? Which is important. Okay, so population means they're looking at all the ears of corn right? So that's why it went back to say, well, we're looking at average levels of residue of 3 pesticides for all the corn because we're talking about our bigger group when it's the population parameter. Sample statistics is now going to bring it down to what they actually looked at, right? So the sample statistics would describe the sample, right? It's not going to describe not going to describe the whole population, although we could make inferences on the whole population, but we're going to describe the average levels, average residue levels of the 3 pesticides that they actually measured, right? So and the thing that they actually measured was their sample, right, which was the 25 ears from each farm. It's impossible for them to measure all the ears of corn, but they took some sample statistics and looked at the average from our 25 from each farm, right? Population, the whole group. Sample, a part of that group. Population parameters basically means what are you actually trying to figure out, okay? And it's always going to refer back to the whole group. Even if you weren't able to look at the whole group, population parameter is going to look at the whole group. You might have to make an inference to get that. Sample, which means a prediction, right? Sample statistics means what were the actual numbers that you got from the corn that you looked at? What are your from your sample? Okay. Questions about that stuff? Okay. So, basic steps in a statistical study. You want to state the goal of your study. Okay. I think on this next project, that's going to be important that you're able to kind of go. That's why I want you to kind of be thinking forward. You're going to have to do a survey. So you want to kind of get in mind what you want to do. But you've got to have a goal for your study. If you don't have a goal, then it's hard to say that what you're doing is on the right track, and we're going to talk about some examples about that. But number 2, choose a representative sample from the population. So most of the time, it's not possible to survey or to look at the whole population, so we want to take a sample of that. We want to collect some raw data from the sample and summarize these data by finding sample statistics of interest. I'm going to post these notes so you don't have to copy all this stuff down. Use the sample statistics to infer the population parameters. Okay, that means that, oh, look, I got these numbers about these 25 ears of corn, and here's what I found out about pesticides. Now what can I say about all the corn? Okay, and then we're going to draw conclusions. So that's kind of the steps you want to go through, and like I said, I'll post this in the course content. But here's our example. So each month, the U.S. Labor Department surveys 60,000 households to determine characteristics of the U.S. workforce. One population parameter of interest is the U.S. unemployment rate, defined as the percentage of people who are unemployed among all those who are either employed or actively seeking employment. That's important. So we're looking at among all those who are either employed or actively seeking employment. There would be another group of people, right? People that are unemployed, but they're not looking for a job, right? And then maybe they can't, but they might be disabled or something like that. But describe how the 5 basic steps of statistical study apply to this research. So what's the goal of their study, right? They're trying to learn about the employment or unemployment within the population of all Americans who are either employed or actively seeking employment. So their goal is to try to learn about employment or unemployment. And a lot of the questions in your the lab assignment for this, not the lab assignment, the homework assignment are like this. They're going to ask you to kind of analyze this stuff. Learn about all the employment and unemployment and yes, I can do that. I can put the completed notes on there too. That I will do that. Um, Employed or actively seeking employment. Okay. So, step number 2. Well, how are they going to find this out? They're going to have to choose a representative sample from the population because they cannot survey every single American. That's not going to happen. So, it says that up here that the Labor Department chose a sampling consisting of people employed or seeking employment in 60,000 households. So, they basically picked 60,000 households that were employed or seeking employment to survey. Okay, I don't know how they went about doing this, right? They might make phone calls and get to, and the person answers the phone, and if they weren't actively seeking employment, right, if they're disabled or something like that, they may have to not count that one in their 60,000, right? So, step 3. You want to collect the raw data from the sample and summarize these data by finding sample statistics. So the Labor Department asks questions of the people in the sample, and their responses constitute the raw data for the research. And they're going to put that raw data, so they're going to ask questions from these people. They're going to use the data to make statistics. Basically, how many people are employed, how many people are unemployed, those kind of questions. So then they're going to use their sample in statistics to infer population parameters. In this case, remember, population refers back to the entire United States, not our 60,000 people. So based on the sample statistics, the Labor Department makes estimates of the corresponding population parameters, such as the unemployment for the entire United States. So they're going to make they're going to take that 60,000 and apply it to the entire United States. So they're going to infer the statistics for the entire U.S. What does that mean? So let's say they came up and said, well, there's 20% unemployment among these 60,000 people. So now they're going to say, well, that's probably pretty representative of what's happening in the United States. So if there's 2 million people in the United States, how many people are unemployed? They're going to use what they learned to talk about the entire population, not just the 60,000. Okay, and that is really, really like this whole COVID thing. There's so much math involved in, okay, well, we looked at this population, so now we think we can make a general statement about the entire population and make some kind of prediction about what's actually happening. Okay, we're going to draw conclusions. So the Labor Department draws conclusions based on the population parameters of the other information. For example, it might use the current and past unemployment rates to draw conclusions about whether jobs have been created or lost. So this, they might look in the past and use what they found now and the present predictions to decide are we creating jobs or losing jobs, and I'll put the exact wording on the thing, but are we creating jobs, are we losing jobs? They're going to draw some conclusions about what they found. Okay. So that's the kind of steps you want to go through when you're doing your experiment. You want to make sure that you got all that stuff. So how do we go about finding sample sizes? Okay. Simple random sampling basically means that you choose a sample of items in such a way that every sample of the same size has an equal chance of being selected. Okay, so I'm just going to say equal chance of being selected. So if I was in a classroom of 25 students, right, and I had, as you come in the door, you put your name on a piece of paper and you put it in a little bag, fold it up, and I draw it, right? That's like simple random sampling. Everybody would have the same chance to win, okay? Unless somebody folded their paper different or something. But, right, I'm just drawing it out of the hat. If a computer has 100 numbers in it and the computer has some kind of random pattern where it pulls 5 numbers, okay, that would be a sample of random sampling, because every one of those 100 numbers has the exact same chance of being pulled. Okay, systematic sampling is different because you want to, so an example of this would be select every 10th member. Okay, so if I'm standing outside the door of Pulaski Tech in the morning and I'm doing systematic sampling, I'm going to survey the first person, right? And then I'm going to say, okay, I'm going to count, let 10 go by. I'm going to survey the 11th person, right? Then I'm going to let 10 go by, survey the 21st person. Let 10 go by, survey the 3rd. I have a system that I'm putting into place where I only survey these people because they're every so often. Does that make sense? That's systematic sampling, which just makes sense. If that's what convenient sampling, this picture cracks me up. But basically, this person is calling out of their apartment or their dorm or whatever, and it says, hey, do you support the death penalty to this person that's outside walking their dog? Okay, which that's just crazy. But basically, a convenient sample is doing something because it's easy. So it's convenient, it's easy. So what does that mean? For me, if I was doing a graduate project on some kind of mathematical research, well, I have 175 students this semester, so it would be really easy for me to just say, well, I'm just going to give all my students the survey. That's where I'm going to get my information. That's convenient. That's convenient sampling. If you are, I would say you're going to the football games Saturday in non-COVID times, and you're like, oh, I got to get this project done for my statistics class, and you just go, I'm gonna survey 20 people that are sitting around me at the football game. If I'm standing outside of Walmart, that's kind of a easy way, convenient sampling. Just go somewhere, get it done. Okay, stratified sampling. This is the kind of sampling I'm going to try to. This wording is really long, but basically I'm going to read it and then I'm going to summarize it for you. But we use this method when we are concerned about difference among subgroups or strata within a population. We first identify the subgroups and then draw a random sample from each subgroup. Okay, so we want to have a subgroup. Say we have, I'm just going to draw a picture. So you got subgroups and you take a sample from each one of those subgroups. You decide, okay, I'm gonna pick 5 of these and 5 of these, okay? And we'll talk about why you would want to do that later, but if I go to I got football in my mind right now, I don't know why, sorry. If I go to the Razorback game and I am interested in knowing something about sports, who's there, what kind of fans we have, and I survey the Razorback football team, well, I'm going to get one particular type of answer because unless something's changed since the last time I watched, that we don't have any women on that team. So that's only going to get me information from a male's perspective, which is not necessarily bad, but it might not give me a picture of what I'm actually trying to figure out. Okay, Splasky Tech is a pretty diverse place to be. Um, I have students from several different backgrounds, several different ethnic groups. If I went into a class and didn't take that into account, that might distort my research. So I might want to say, well, I would like the opinion of one Asian person, or it depends on how many students I have, but I might want to make sure that I'm getting a representative of what everybody thinks instead of saying, does that make sense? So I might want to pick a certain number of each set of population so I can make sure that my research is actually good. And it's not always even appropriate to do that, but sometimes it's necessary. Okay, so that's stratified sampling where you go, okay, I want to make sure I get these, and this is what this picture of is of. They've got women and men, and they say, well, we want to make sure we get 2 women's opinions and 2 men's opinions over here. So that's what that is. Okay, so let's see if we can identify what these were. So the first question says so we're supposed to pick among those 4 things. You are conducting a survey of students in a dormitory. You choose your sample by knocking on the door of every 10th room. What? Let's go back up here and look. Systematic. Yeah, every 10th room, you've got a system in place. So that's going to be, this one's going to be systematic sampling. To survey opinions on a proposed new water line, a research firm randomly draws the addresses of 150 homeowners from a public list of all homeowners. Random, right? Everybody has an equal chance. That's just random sampling. Everybody has an equal chance. They're just drawing the names out of a hat, basically. Okay. Agricultural, this is the one we went over earlier. Agricultural inspectors from Jefferson County picked the levels of residue from 3 common pesticides on 25 ears of corn from each of the 104 corn producing farms. Stratified. Perfect, because if they just looked at 3 or 4 farms, that might not really represent what's happening in Jefferson County. They need to stratify that so that they can look at a little sample out of each one of the farms. Okay, anthropologists determined the average brain size of early Neanderthals in Europe by studying skulls found at 3 sites in southern Europe. This one is convenient, which it doesn't seem like it's convenient, but okay, one reason they must be in Europe. Well, it says, I mean, they're only looking at one place, so they must be there, right? So they didn't even worry about looking anywhere else in other continents. So they just did what was easy for them, which doesn't necessarily mean that's a good thing, okay? Convenient sampling a lot of times is not what the best method is going to be, which we know in basic life that a lot of times doing what's easy is not necessarily going to get you the best results. So, okay. So we know we've talked about a whole lot about what bias means in just everyday language. We know that if you're biased, the definition in math is that a statistical study suffers from bias if its design or conduct tends to favor certain results. Okay, so a little bit different than like how you would use the word in your regular vocabulary, but basically you've designed this so it's going to work out in your favor. My son was involved in a research project at UAMS, and the doctor that was over him was frustrated because the research wasn't working out like he wanted it to. It wasn't what he thought it was going to happen, right? And he had gotten all this money for it. So it would have been really easy for that doctor to have tried to make it kind of turn it a little bit so that he was finding things that he wanted to find out instead of, right? So you want to be careful that your research is not biased because you thought it was going to come out this way or you wanted it to come out this way and it's not. So we've got some different kind of studies that we're going to talk about. Observational study is basically researchers observe or measure characteristics of the sample members, but do not attempt to influence or modify these characteristics. So we're going to observe, just makes sense. We're going to observe, and while we're observing, we could measure, but we're going to observe or measure some characteristics of a sample, and basically without influencing it. Okay, so we're going to watch what's happening and we're going to observe what's happening. We're going to write it down, but we're not going to try to influence it. Okay, in an experiment, you're going to research, we know this, researchers apply a treatment to some or all of the sample members and then observe what happens, right? So observe the effects. So you apply something to the sample. We're going to do something to somebody, right, or something, and then we're going to observe the effects. We're going to look and see, well, if I do this, what's going to happen? That's an experiment. Okay. The treatment group, that's self-explanatory, right? These are the people that are basically receiving the treatment. We could even say these people are receiving the treatment or the experiment, right? They're the ones that are getting experimented on or receiving the treatment. Control group, you've probably heard of that before. These are the people who do not receive the treatment. Sometimes they call it like they'll give them I've heard this done a lot in diets, but if it's a diet pill, they might give these people a water pill instead of the actual pill, so they don't receive the treatment or the experiment. They get something called the placebo, which is just fake. So the treatment group's the people who actually get the treatment. The control group are the people that don't receive the treatment, but they might receive something that they think is a treatment, right? They're the control. Okay, it's important for the treatment and control groups to be selected randomly and to be all alike in all respects except for the treatment. Okay, so I'm going to talk about placebo, which is what I was saying, was that like that water pill or something. A placebo lacks the active ingredients of a treatment being tested in a study, but looks or feels enough like the treatment so that the participants cannot distinguish whether they are receiving the placebo or the real treatment. Okay, blinding. If you have a single blind study, this is when the participants do not know whether they are members of the treatment group or members of the control group, but the person doing the experiment knows. So the participants don't know, but the researcher does know. Okay, so the person doing the research knows this person's getting the placebo, that person's getting the real thing. They know the difference. If it's double blind, the participants they don't know, and the researcher doesn't know. The participants don't know, and the researcher doesn't know. And you might say, well, how in the world does that work? Well, there would have to be a third party that actually has the information of who got the real thing and who doesn't. But the person doing the research doesn't know, and the participant doesn't know. And that actually is probably the best way to go about doing that. And we'll talk about why. Okay, we're going to talk about example 4, and then I'm going to call it. So we're just going to look at this one, and then I will record the rest of this on Friday and post it. But for each of the experiments described, identify any problems and explain how the problems could have been avoided. Okay, and I don't think I'm gonna talk about this. I'll post the notes. I have this written down. But it says a chiropractor performs an adjustment on 25 patients with back pain. Afterward, 18 of the patients said they feel better. He concludes that the adjustments are an effective treatment. Okay, so what's wrong with that? I mean, if you go to the doctor, you kind of have some kind of expectation that whatever they give you is going to make you feel better, right? So you kind of already have it in your head. Plus, if it's me, I paid a lot of money, and I want it to work because I'm out all that money and all that stuff, right? So in my head, even if it didn't work that great, I'm probably going to try to convince myself like it did, right? So if he really was going to do an experiment, he probably needed to have something where he mimicked or did something to the person that wasn't the right treatment, or maybe was a different. That would be difficult to do, I imagine, in a chiropractic setting. But he would need to mimic something that was perform a treatment on somebody that really wasn't for treating that, and see if the control group or which one was better. Okay. Part B says a new drug for a type of attention deficit disorder is supposed to make the affected children less disruptive. Randomly selected children suffer from the disorder are divided into treatment and control groups. Those in the control group receive a placebo that looks like the real drug. And the experiment is single blind. Remember, single blind means that the kids don't know who got the real drug and the fake drug, but the person doing the experiment knows. The experimenter interviews the children one-on-one to decide whether they became more polite. Well, what's not good about that? Well, if the experimenter person really wants this drug to work, right, has some kind of money invested in this drug, I can guarantee you that they're going to be a little bit more biased, and they're going to look at that kid that they knew took that drug, and their perception of whether that kid is better or more polite or calmer, I guess, is going to be skewed, is what we would call it in math. They're gonna look at them, and they're gonna perceive maybe that they're more polite than they actually are, because they know that that child took the drug and not the placebo. So to make this experiment better, we would probably need to make it double blind, right? Where the experimenter doesn't know which child took the real drug and which ones took the fake water pill. And the third party or someone else could have that information, but they don't need to know it because they would try to move it to be the way they want it to be. Does that make sense? Okay, so we're going to finish up chapter 5A on Friday.